It may have been one small step for Endeavour, but it was one giant leap for NASA. America's newest space shuttle rolls to the launch pad just 10 months after rolling off the assembly line in California. Endeavour is now locked down at Pad 39B, where final checkouts are underway. The excitement continues to build as the maiden voyage of the space shuttle Endeavour draws near.
President Bush nominates Daniel Golden to replace Richard Truly as head of NASA. If confirmed by Congress, the TRW executive is expected to shift emphasis away from the shuttle and focus it on other programs, such as a manned mission to Mars.
Dan is a leader in America's aerospace industry and a man of extraordinary energy and vitality. Working with the Vice President as chairman of the Space Council, Dan Golden will ensure America's leadership in space.
Four shuttle veterans and 3 newcomers are aboard the Space Shuttle Atlantis as it roars into orbit. Charlie Bolden is the commander of STS-45, another in a series of missions to planet Earth. This flight carries Atlas I, a $52 million instrument package designed to study interaction between the Earth's atmosphere and the Sun.
1 second. We have a go for auto.
Specialist Jay Aft.
And liftoff of Atlantis and the Galileo spacecraft.
I have preconceived notions. I wanted a tip off is not great.
The only thing absent was family and friends, but
nose gear touchdown.
For March 1992, this is Shuttle Vision, Volume 1, Number 4.
Hello, I'm Tom Marshall.
And I'm Richard Horman. We're on location this month at the Jet Propulsion Laboratory in Pasadena, California. We're seated in front of a life-size mock-up of the Galileo Jupiter probe, which at this very moment is traveling more than 33,000 miles per hour en route to Jupiter. JPL is NASA's nerve center for the various planetary probes throughout our solar system, which are sending a steady stream of data back to Earth. A little bit later on in the program, we'll take you behind the scenes of JPL and show you just where all that telemetry ends up.
We'll also update the status of Galileo, Magellan, and Ulysses, and we'll take you to the Kennedy Space Center in Florida for the rollout of Endeavour. But topping Space Shuttle news this month, the nomination of Daniel Golden. The word came from the White House on the morning of March 11th. Daniel S. Golden was the Bush administration's pick to head the space agency. The announcement was made 1 month after Richard Truly was forced out as NASA administrator. Shuttle Vision's Anita Vogel is in Washington this month, where she's been following the Golden nomination. Anita, what can you tell us?
Well, Tom, I'm standing in the Science, Space, and Technology Subcommittee on Space hearing room here on Capitol Hill. A Senate subcommittee headed by Tennessee Democrat Al Gore is handling the Golden nomination. These hearings, which began a few days ago, are expected to conclude later this month. Committee members will grill Golden on a variety of space-related issues, including his goals for NASA, international cooperation in space, and undoubtedly his stance on the President's Strategic Defense Initiative program. As we told you last month, the NASA nominee would likely have a favorable attitude toward SDI, and Daniel Golden has just that. The 51-year-old aerospace executive has extensive experience in the defense industry, having overseen the development of a number of spy, early warning, and military communication satellites. One of his most recent projects at TRW was the centerpiece of the Bush administration's Star Wars anti-missile plan. Codenamed Brilliant Pebbles, the $380 million program would place in orbit a network of satellites capable of destroying enemy missiles. But not all of Golden's work has been military-oriented. In the late 1960s, he was already pioneering research on a propulsion system that could send astronauts to Mars. He conducted this research at NASA's Lewis Research Center near Cleveland, where he began his professional career after graduating from the City College of New York in 1962. He continued to study the feasibility of interplanetary travel after joining TRW 5 years later. Golden went on to work on NASA's Communication Technology Satellite, the first high-powered direct broadcast TV system. On the civilian end, Golden is probably best known for his budget-minded leadership of NASA's Tracking and Data Relay satellite system and the Compton Gamma Ray Observatory. During his tenure at TRW, the aerospace firm built the TDRS system on time and within budget.
All the folks, out at Sunnyvale and TRW and Goddard.
If Golden is confirmed by the Senate, he will be leaving his post as Vice President and General Manager of TRW's Space and Technology Group in Redondo Beach, California, his most recent position as a rising star in the world of space contractors.
Dan is a leader in America's aerospace industry and a man of extraordinary energy and vitality. Working with the Vice President as Chairman of the Space Council, Dan Golden will ensure America's leadership in space as we enter the 21st century.
Golden was not at the White House on March 11th when President Bush made the announcement. A spokesman at TRW said the nomination came as a complete surprise to the company. Apparently, TRW wasn't alone. Space experts on and off Capitol Hill were caught off guard by the news. Some even admitted they had never heard of Daniel Golden before. From the Kennedy Space Center in Florida, KSC Director Robert Crippen issued a statement saying, quote, "While I do not know Daniel Golden personally, I am sure the President, who has made a strong commitment to the nation's space program, has nominated someone he is confident can lead NASA through the very challenging and exciting years ahead of us. I look forward to working closely with the new administrator." End of quote. Senator Al Gore, meanwhile, greeted the news with an air of skepticism, saying Golden would receive serious scrutiny. He said he had strong concerns regarding the influence of the National Space Council, which is headed by Dan Quayle. In fact, 2 days after the announcement, Quayle tightened the NSC's control over space activity by dividing NASA's responsibility for the Moon and Mars projects among several government agencies. While NASA will serve as the principal agency overseeing these programs, the Bush administration assigned major roles to the Defense and Energy departments. This shared responsibility is regarded by many as the next step in the NSC's overhaul of NASA, an effort initiated in February with the ousting of Richard Truly. The former astronaut, who was to leave the space agency on April 1st, issued this statement following the nomination. Quote, "I am pleased to learn that President Bush intends to nominate Daniel S. Golden as the next administrator of NASA. Mr. Golden has a long history of working in the space arena, in both NASA and DoD programs, and the NASA team stands ready to support him. The continued achievements of NASA's space and aeronautics research programs are vitally important to the nation, and Mr. Golden will be arriving at a time of great challenges and opportunities for the future. I wish him every success as he comes to this elite organization." End of quote. Bush did take time out to acknowledge the achievements of the outgoing NASA administrator.
And I want to acknowledge the work of Admiral Dick Truly in providing valued leadership in the space program as an astronaut and as the administrator of NASA. He deserves great credit for so many of the successes of our space effort.
Shuttle Vision did speak to Daniel Golden prior to the start of the confirmation hearings, but he didn't want to go on the record with any of his comments before the Senate had its chance to query him. When we spoke to him, he was working 12 to 18-hour days just to keep up with all the paperwork that needed to be filed prior to the hearings. Once the rush is over, we hope to sit down with Mr. Golden and talk about the future of NASA and the Space Shuttle program. In the meantime, the Senate subcommittee is doing just that. Frank Setson Jr., a senior technology writer for Space Business News, joins us now to help shed some light on the nominee. Mr. Setson, thanks for joining us today.
Hi, Anita.
Now, you've been covering the space program for many years now, along with the politics behind it. How would you characterize the nomination of Daniel Golden?
The Golden nomination is probably a change of pace in the last several types of NASA administrators. He brings a business background. He is one of the younger NASA administrators in recent years. And also, in addition to that, he has some new and fresh ideas. His management background, for example, has been small programs. So he brings a change in the culture of the agency to NASA at a very critical time in NASA's history.
Would you say he's the right man for the job?
The most successful NASA administrators of the last several years have been those that have taken the political vision of the presidents that appointed them and framed it in terms of which the bureaucracy made it their central reason for existence. That was the case, for example, with Jim Beggs in the space station, Jim Fletcher with the space shuttle, and going back to the Apollo days and Jim Webb. Dick Truly's biggest failure, if you could call it a failure, is his inability to have taken President Bush's space exploration initiative and make that the centerpiece of all of NASA's thematic approach. Golden is going to have to come in now after Truly take all the disparate elements of NASA programs, the new thrust toward exploration, and make that into one single NASA fabric to make it difficult for critics to pick off several NASA programs one at a time. And in that sense, he's got several people here on Capitol Hill nervous because he hasn't had a policy background or the opportunity to get involved in those kinds of issues before.
How do you think NASA managers in Houston and Florida are viewing this changeover?
Most of the NASA managers that are involved in manned spaceflight issues are very nervous because he has in the past expressed some criticism at the amount and extent of the NASA budget that's spent on programs, for example, like the Space Shuttle or the space station. Golden, in response, has indicated to the bureaucracy, at least, that one of his first tasks after being confirmed by the Senate will be to move out toward the NASA field centers at Marshall and JSC and KSC and make certain that they understand that he is not anti-manned spaceflight. So until such time as he's had a chance to actually go out and begin to absorb some of the programs and set some new policies and new directions, they're going to be very cautious about his appointment.
And finally, how do you think Dick Truly is viewing this turn of events?
Dick Truly is unhappy for a variety of reasons, not the least of which, of course, is the fact that he was fired in the middle of his term. He has, in a very real sense, brought to an end a historic, diverse era of NASA administration, going back to the Challenger accident when astronauts were placed in major and serious positions of administrative power. Golden, I think, was going to have a difficult time in keeping all of the other players that the administration has put into the space policy mix, such as the Department of Energy and the Department of Defense, keeping NASA above and in control of the issues. In that sense, Dick Truly, I think, feels that he did not leave a strong administrative legacy outside of his brilliant management of the shuttle, and I think he's a man that's leaving town that's at least a little bit unhappy. His last speech to the National Space Club, he read a poem at the end called Ode to Being Stepped On.
Okay, Frank Setson, thank you very much for joining us today.
You bet.
Tom?
Anita, now that Congress has had a few weeks to read up on Dan Golden, what's the sentiment towards him in the Senate?
Well, Tom, although some senators have questioned Truly's sudden departure, most are pretty confident with Golden's abilities to lead NASA. It's expected that some questions will arise concerning his involvement in various TRW contracts relating to SDI, but overall there appears to be little opposition.
And what about House representatives?
Well, Tom, even though the House has no official role in the confirmation process, supporters of the space program are concerned that Golden's appointment will have a much longer-term impact. If key Democrats perceive that Golden is carrying out Quayle's personal space agenda, then funding for future projects could be in jeopardy. However, my sources here on the Hill tell me that KSC Director Robert Crippen was here just a few days after Golden's nomination, and that he told a leading Florida Democrat that the mandate for the shuttle program would not be in jeopardy, and that future projects would go along as scheduled. Now, if that's the case, key supporters here in Congress should be resting easy, and that should also make the confirmation process for Golden much easier. Back to you, Tom.
Thanks, Anita. We'll check back with you later on in this hour. Well, the other big story to tell you about this month is the rollout of the Space Shuttle Endeavour. The orbiter is now in a launch position at Complex 39B at the Kennedy Space Center in Florida. The rollout is one of the last major milestones leading up to the maiden flight of Endeavour, the jewel of NASA's orbiter fleet. Friday the 13th turned out to be a lucky day for workers at KSC, who helped transport the vehicle out to the launch pad. The first move came at 8 a.m. Eastern Time, when Endeavour left the vehicle assembly building atop its mobile launcher platform. The platform was connected to NASA's crawler transporter, which moves at a maximum speed of 2 miles an hour. It's the largest land vehicle in the world, weighing 3,000 tons. The transporter has 4 double-tracked crawlers, which follow a paved path to the pad. The 4.2-mile trip to NASA's Northern Shuttle launch facility took more than 6 hours to complete. Launch Director Bob Seek was among those who turned out for this historic event. It was the first time in 7 years a new shuttle debuted at one of the launch pads at KSC. The last time a new shuttle was rolled out for its maiden flight was in 1985, when Atlantis was moved to Pad 39A for a DoD flight. Endeavour is preparing to rocket into space in May on a rendezvous mission with a communications satellite. A pair of astronauts aboard Endeavour will conduct 3 spacewalks, the most ever conducted from a shuttle during a single mission. The astronauts will capture the satellite, bring it into Endeavour's cargo bay, and attach a new motor to it. STS-49 will be a 7-day mission, but the orbiter has been fitted with internal plumbing and electrical connections that could enable a spacecraft to stay in orbit for as long as 28 days. Although the shuttle is not yet equipped with the additional nitrogen tanks needed to support extended missions, its internal systems can accommodate the necessary hardware once it's installed. From a distance, Endeavour's launch will probably look like any other shuttle takeoff, but when it returns to Earth, you can expect something new. Endeavour will be the first orbiter to have a drag chute deployed upon landing. Engineers install the 40-foot diameter canopy in a compartment located just below the orbiter's tail. The drag chute installation was part of the preparation Endeavour underwent while stationed at the orbiter processing facility at KSC. The drag chute will trail 87 feet behind the orbiter as it rolls out after landing. The main drag chute and a 9-foot diameter pilot chute will be deployed between main gear and nose gear touchdown. The device is expected to provide the orbiter with greater stability in the event of a flat tire or a steering problem. Endeavour was situated in the OPF for 7 months after arriving from the assembly plant in California last May. In addition to installing major flight components, the shuttle team resolved literally hundreds of problems with Endeavour, including scratched and gouged structural beams, crossed wires, exposed electrical connectors, and dirty fuel lines. There was some concern that these problems, many of which were unexpected, would delay Endeavour's debut. But on March 7th, Endeavour was towed several hundred yards from the OPF to the massive vehicle assembly building for mating to its external tank and SRBs. Hundreds of space workers cheered and snapped pictures as the shiny new black and white spaceship was slowly moved to the VAB. A recording of God Bless America boomed from loudspeakers as the $2 billion replacement for the Space Shuttle Challenger inched towards the assembly building. Endeavour spent 6 days in the VAB, where technicians connected the spaceplane to its external tank. With Endeavour now on the pad, its next hurdle was to be a flight readiness firing, which was scheduled for the first week in April. This 20-second test firing of the shuttle's main engines is a required test of all new shuttles to verify the integrated operations of the 3 main engines. It also checks out the main propulsion system and pad propellant delivery systems. After the FRF, technicians will perform extensive inspections of Endeavour's engines to make sure its systems are flight ready. About 4 days after the FRF, the STS-49 flight crew will take part in a terminal countdown demonstration test. Endeavour's 7-member crew will be commanded by Chief Astronaut Dan Brandenstein. Kevin Chilton is the pilot, and the 5 mission specialists are Rick Heeb, Pierre Thuot, Kathy Thornton, Thomas Akers, and Bruce Melnick. NASA managers will not set an official launch date until after they've had a chance to study the results of the flight readiness firing. But a KSC spokesman told Shuttlevision NASA is targeting May 7th as a launch date. Shuttlevision will provide you with complete coverage of the flight readiness firing next month as we go on location to the Kennedy Space Center. In fact, we'll be in Florida for the next few months as we continue our countdown to Endeavour.
Two key space station support facilities were dedicated at the Johnson Space Center in February. The Space Station Control Center and the training facility will serve as the nerve center for Space Station Freedom once it's assembled in orbit later this decade. JSC Director Aaron Cohen was on hand for the ceremony, which christened the complex that will serve as mission control for Space Station Freedom. The control center that is used for shuttle flights now will continue to monitor orbiter activities, while the new state-of-the-art control center will handle all space station-related operations. Meanwhile, a life-size replica of Freedom will be housed in the training facility.
Think of this facility not as some high-tech control room, but as a gateway, as a point from which our imaginations can soar, our technologies can be honed, and our accomplishments can point the way to a better future for all of us. Thank you very much.
The training facility will begin operations in 1995, with the control center going online the following year. The combined price tag for the two facilities, $822 million. The Titan III rocket that will launch the Mars Observer spacecraft arrived at the Kennedy Space Center on February 28th. The booster, built by Martin Marietta in Denver, is targeted for liftoff on September 16th, which is the start of the Mars planetary launch window. Mars Observer is the first mission to that planet since the Viking program in 1976. It is the first spacecraft in a series of lower-cost planetary missions developed right here at the Jet Propulsion Laboratory. In addition to Mars, future missions in the series will explore Venus, the Moon, and near-Earth asteroids and comets. Well, talking about Mars, astronauts may someday explore that planet without ever leaving the launch pad. They'll do it using something NASA calls telepresence. It's a unique mix of science and engineering that is in development at the space agency. Telepresence lets a researcher wearing a video headset see remote locations through cameras mounted on a remotely operated robotic vehicle. The researcher points the camera by moving his or her head and steers the vehicle with a pair of joysticks or with body motion. Manipulators on the robot relay the feel of an object's weight and texture. Telepresence is similar to virtual reality, another computer science innovation that also uses a video headset. While virtual reality allows a user to see and interact with a computerized video image, telepresence allows a researcher to perform actual tasks in a real environment.
With telepresence, we think that we can really expand the range of access to the surface of Mars from a scientific perspective, not just in terms of operating, relatively simple robots to do things like construction, but really to do scientific field work.
Many scientists believe telepresence will play a major role in future planetary missions, including the President's Space Exploration Initiative, which calls for the return of humans to the Moon and eventually Mars. In the meantime, a mini fleet of satellites is traveling throughout our solar system, sending back a wealth of information about our celestial neighbors. What are these interplanetary probes telling us? Well, that's the topic of this month's cover story. Over the last few years, NASA's Space Shuttle fleet has launched a trio of spacecraft, beginning a second phase of robotic exploration of our solar system. Initially sent to every planet except Pluto, these satellites have detected planetary atmospheres reminiscent of early Earth. Evidence of water, active volcanoes, planetary rings, and even giant storms were discovered. Scientists believe the information gathered from the other planets will help us understand our own.
Very good.
There she goes. We have a deploy.
In May of 1989, the Magellan spacecraft was released from the cargo bay of the Space Shuttle Atlantis. Its purpose was to map the surface of Venus, a planet that is similar in size and density to the Earth.
It's really the most Earth-like of all the planets in the inner solar system. It's about the same size and density of the Earth, and therefore we think that the surface geology of Venus should be pretty similar to that of the Earth. Therefore, we want to try to study it to understand what the range of features that we see on the surface are, how the surface has evolved, and how similar or different it is to the Earth.
Magellan is equipped with a high-resolution radar that sees through the planet's thick, cloud-choked atmosphere. Mapping has been underway for the last several months at JPL, where scientists like Ellen Stoffen have been piecing together the surface of Venus.
As you can see from the globe, we've actually mapped over 95% of the surface. The way we map is that we map in very long, thin strips that are about 12 miles wide and about 10,000 miles long. Some of the very thin black lines that you see on the globe are orbits that we've missed for some reason or another. Then these orbits are mosaic together, then we can lay them over top of a globe to really get a complete picture of the surface of Venus.
Using the same data, computers have also been able to produce this video, simulating a flyby across portions of the planet.
I think that the mission has truly been a great success for NASA and for the Jet Propulsion Laboratory, and we're all terribly excited about the scientific data that's going to be analyzed over the next several years.
Jupiter is the ultimate destination for Galileo, launched in October of 1989. After reaching the giant gaseous planet in late 1995, Galileo will deploy a tiny probe which will penetrate the atmosphere and radio back data. The malfunction of Galileo's high-gain antenna is not expected to affect the probe portion of the mission. However, the stream of data back to Earth has been slowed because the satellite's large umbrella-shaped antenna has refused to unfurl. Mission Director Neil Osmond said excessive transport of Galileo on the ground before launch may be to blame for the hitch.
We had dry lubricant on the pins, dry lubricant on the receptacles when the spacecraft or the antenna was initially delivered. These treks back and forth across the United States, we postulate, wore off the dry lubricant and in fact abraded the receptacle and the pin connection such that we could have increased friction forces at the point where the pin and the receptacles touch. We think it will take somewhere between 6 and maybe 9 of these warming, cooling maneuvers, maybe as many as 12, of these warming, cooling maneuvers to walk the pins out if all of the analysis we've done is in fact correct and we're really dealing with the correct failure scenario.
Osmond said his team of scientists will know by next March whether or not this procedure will be successful. In the meantime, scientists have been studying other pictures provided by the spacecraft. Along its way to Jupiter, Galileo is picking up energy by utilizing gravity assist while traveling once by Venus and twice by Earth. This is what Galileo saw when it came within 600 miles of Earth on its first pass. Hundreds of images were combined over a 25-hour period to give a view never seen before of the whole Earth in motion. Images of the Moon were also taken, which include rare glimpses of its far side. Once Galileo reaches its destination and the probe is deployed, the spacecraft itself will utilize 10 experiments to study Jupiter's 16 moons, its atmosphere, radiation, and magnetic fields. The spacecraft Ulysses, meanwhile, has been sent to the Sun to study the never-before-seen solar poles. It is a joint project between NASA and the European Space Agency.
Ulysses' goal is to study the Sun's heliosphere as a function of solar latitude. All we know about the Sun we've studied from the equator or the ecliptic plane in which the planets orbit the Sun. And with this spacecraft, we get a chance to go up from the ecliptic plane to a latitude of about 80 degrees, and we're taking data all the way up, so it gives us a complete picture of the Sun's atmosphere. From Ulysses, you are going to get information about the Sun, which might help us understand the weather, might help us understand communications better. We got these sunspots coming off the Sun, and even in studying the cosmic rays, those cosmic rays carry information about the origin of the universe. If you can determine the speed, the direction from which they come and their composition, that lets you know about the source or the origin from which they came. And you might learn a little bit more about the Big Bang Theory, which is a reigning theory for how the universe began.
The voyage of Ulysses, like that of Magellan, may be extended if funding is allocated for ground support, a prospect that is growing less and less likely as a budget-minded NASA shifts priorities.
The spacecraft, we think, is in pretty good shape, and in order to complete another loop, we just need funding. Now, the limiting consumable on the spacecraft is power. We've taken a look at that, and it appears that we do have enough power to complete another pass, another solar pass, and I would make the mission once after launch go for about 11, 12 years. There is tremendous scientific justification for doing another mission. We're only seeing part of the solar cycle. In the 5 years that we're going, that's just probably 1/4 of a solar cycle. It takes about 22 years to complete the total solar cycle, and we feel that it would be well worthwhile for the scientific community to have those data.
I think it's hard for all of us that have worked on the spacecraft over the last several years. It sort of becomes more your child than this hunk of metal out in space. So it's always hard to think of the spacecraft eventually dying. But really, we like to think back over the last few cycles of mapping of Magellan and just the incredible wealth of information that it's returned. Right to date, it's returned more data than all U.S. planetary missions combined.
But monetary problems on Earth aren't likely to diminish man's desire to fulfill a higher calling.
We need to know more about our solar system, and it is robotic spacecraft like Galileo and the Magellan spacecraft like Voyager before us that are the vehicles that will give us this insight to how our solar system works, the physics that control our solar system. And of course, by knowing more about our solar system and how it works, we understand more about Earth. So you have technical reasons, understanding more about our home planet, and psychological or philosophical reasons, it's man's destiny to explore, and these are the devices that we're using to explore the planets.
7-member crew of Atlantis mission STS-45 was launched into space on the morning of March 24th. The liftoff was postponed one day after sensors aboard the orbiter detected liquid hydrogen and liquid oxygen leaks in the engine compartment. Engineers said the leaks were the result of a faulty seal between the external tank and the orbiter.
We experienced a transient leak in both the liquid hydrogen and liquid oxygen systems as detected by our instrumentation in the aft fuselage of the orbiter. Since both of those leaks appeared to have occurred almost simultaneous, the team did the prudent thing, stopped the flow on the hydrogen. We've already taken a quick look at the weather, and it looks acceptable, certainly acceptable enough to make an attempt for tomorrow.
6, 5, main engine start, 3, 2, 1, and liftoff of the Space Shuttle Atlantis on a mission to planet Earth.
The weather did cooperate, and at 8:15 a.m. Eastern Time, Atlantis was on its way. The 46th flight of the Space Shuttle program is the first shuttle mission dedicated to atmospheric research. It is part of NASA's Mission to Planet Earth, a long-term program to study the environment from space. Scientists have been working on this flight for more than 7 years. The mission was originally scheduled for 1986. It was supposed to be the next mission after 51L, Challenger's last flight. Following the shuttle accident, the Atlas mission was put on hold. 13 scientific instruments occupy Atlantis' cargo bay. Most of them are designed to study the atmosphere and solar energy. Scientists say they need to better understand how natural phenomena such as sunlight affect the atmosphere. They also want to find out to what extent man-made pollutants harm it. In addition, the Atlas I instruments were also supposed to observe the links between magnetic fields and electrified gases called plasma that lie between the sun and the Earth. Most of the astronauts' time was to be spent operating an electric beam gun that shoots electrons into the atmosphere in order to generate artificial auroras. Meanwhile, an astronomical telescope will examine sources of radiation in the Milky Way and other galaxies to learn more about the stages in the life of a star. For this mission, the scientific instruments are mounted on a pair of Spacelab pallets in the shuttle's cargo bay. All of the instruments flew on earlier Spacelab missions, and some will fly on future Atlas missions, reducing the cost of this space-based research. Reuse of these facilities will also allow scientists to expand their base of knowledge to provide a more accurate long-term picture of our planet. From Atlantis' 160 nautical mile orbit, these instruments were to be exposed directly to space when the shuttle bay doors were opened. Throughout the mission, the orbiter's position changed frequently to point the experiments toward their targets, the sun, the Earth, and space. STS-45 is the first of 10 atmospheric research missions planned by NASA over the next decade. A mission is planned every year or so to cover an 11-year solar cycle, the period from one peak of solar activity to the next.
4 shuttle veterans and 3 newcomers comprise the crew of STS-45. The astronauts were divided into 2 teams that split 12-hour work shifts in orbit. Going from left to right in the back row, the crew consists of payload specialist Byron Lichtenberg, mission specialists Michael Foll and David Liestma, mission specialist and payload commander Catherine Sullivan, and payload specialist Dirk Fremont. Brian Duffy serves as pilot for the flight, while the commander's seat is reserved for Charlie Bolden. Bolden was born in Columbia, South Carolina on August 19, 1946. He earned a Bachelor of Science degree in Electrical Science from the U.S. Naval Academy and a Master of Science in Systems Management from the University of Southern California. After graduating from the Naval Academy, Bolden accepted a commission in the U.S. Marine Corps. As a naval aviator, he flew more than 100 sorties into North and South Vietnam, Laos, and Cambodia. Following his return to the United States, Bolden graduated from the Naval Test Pilot School in Maryland. He has logged more than 5,000 hours flying time. Bolden became an astronaut in 1981 and has flown in space twice, as pilot for 61C and STS-31. Bolden is 45 years old.
Pilot Brian Duffy was born in Boston, Massachusetts on June the 20th, 1953. He received a Bachelor of Science degree in mathematics from the U.S. Air Force Academy and a Master of Science degree in Systems Management from the University of Southern California. After graduation from the Air Force Academy, Duffy completed his pilot training and was selected to fly the F-15. Duffy joined the astronaut corps in 1986. This is the first flight for the 38-year-old crew member.
Mission Specialist and Payload Commander Catherine D. Sullivan was born in Paterson, New Jersey on October 3, 1951, but she considers Woodland Hills, California her hometown. Sullivan earned a Bachelor of Science degree in Earth Sciences from the University of California at Santa Cruz. She also holds a doctorate in geology. Sullivan is an oceanography officer in the U.S. Naval Reserve, currently holding the rank of Lieutenant Commander. She's a private pilot, rated in powered and glider aircraft. Sullivan became an astronaut in 1979 and is a two-flight veteran. She served as a mission specialist for 41G and STS-31. During 41G in 1984, Sullivan became the first American woman to perform a spacewalk. She is 40 years old.
Sullivan conducted that spacewalk with David Liesma, who serves as mission specialist for STS-45. Liesma was born in Muskegon, Michigan on May 6, 1949. He graduated first in his class from the U.S. Naval Academy and earned a Master's of Science degree in Aeronautical Engineering from the Naval Postgraduate School. Liesma made 3 overseas deployments to the Mediterranean North Atlantic areas while flying aboard the USS John F. Kennedy. He's logged more than 3,000 hours of flight time and has also served as mission specialist for 41G and STS-28.
Mission Specialist Michael Full was born in Louth, England on January 6, 1957, but calls Cambridge home. He attended the University of Cambridge, Queen's College, receiving a Bachelor of Arts degree in physics. Full joined the Johnson Space Center in 1983 in the payload operations area of the Mission Operations Directorate. He was selected as an astronaut candidate in 1987 and completed a 1-year training and evaluation program the following year. This is the first spaceflight for the 35-year-old astronaut.
Payload specialist Byron Lichtenberg was born in Stroudsburg, Pennsylvania on February 19, 1948. He received a Bachelor of Science degree in Aerospace Engineering from Brown University. He also holds a Master of Science degree in Mechanical Engineering and a doctorate in Biomedical Engineering, both from MIT. His doctoral research on the inner ear system led to experiments that flew aboard STS-9, on which he served as the U.S. Flight Payload Specialist back in 1983. Lichtenberg is 42 years old.
Payload specialist Dirk Freemout was born in Poperinge, Belgium on March 21, 1941. He received the degree of Electrotechnical Engineer at the State University of Ghent in Belgium. Freemout is Senior Engineer in the Payload Utilization Department of the European Space Agency. He has been responsible for ESA support to the European experiments aboard Atlas I. He's done that since 1985. This is Freemout's first spaceflight. He's 51 years old.
Down to Byron Lichtenberg.
The STS-45 crew discussed their goals for this mission during a pre-flight press briefing at the Johnson Space Center in February.
We'll be going into what they call a 57-degree inclination orbit, which means we will actually overfly the United States and much of Canada and Europe and things that most of us don't get to see on normal kinds of shuttle missions, if there is a normal shuttle mission. I'm very confident of going to fly, and I think that the process that's in place right now for managing safety and making sure that things are done properly is pretty good.
We have a very big role, I believe, to play in understanding the global environment and all of its interactions with solar system forces through this payload. Some of that we do with our own instruments and their unique independent measurements. Others we do by being able to fit into and leverage what we can do with our instruments by relating our work to other longer-term observing programs.
In the first place, I want to thank NASA to give me the opportunity to fly on this mission. You can believe it's very exciting for me to be part of this experiment. This mission has, from scientific point of view, a lot of interest in the atmosphere. So, like Kathy was saying, it's the first time that we measure as many parameters in the atmosphere on board of one mission. And we have 5 instruments that are devoted to that are measuring the composition and the dynamics of this atmosphere. The composition is, by that we mean trace gases that are there just even in concentrations up to 1 part per billion. These experiments use different methods and techniques, but they all do measurements at the limb. So for that we will have an attitude of the spacecraft with bay down, That is one of our principal attitudes, because these experiments are then working together.
I'd really like to point out that I'm also a new guy, and I'm really eager to be flying on this. This is my first flight with all my experienced colleagues down the table there, except for maybe Brian, who's just as eager as I am, I'm sure. I really want to just let you know how we do all this science. You know, what does the orbit mean, and how do we do all these things? And basically, we lift off in the daylight, and very rapidly, as you probably know, in an orbit that takes 90 minutes to go around the world, we will fly into darkness. And we do this every 90 minutes. We go through a sunset, a sunrise, every 90 minutes. So the way we get all these different parts of the science objectives together, we need to look at the sun, we need to look at the stars, and we need to look at aurora, and also the atmosphere, in particular the limb of the atmosphere, which is the edge between the space and the ball of the Earth as we look at it from space. And the way it will go, once we've unpacked all our gear on board, is to basically turn on Brian or David, who will be flying attitudes in the vehicle, to get us pointing in the right direction so we can look at the right thing at the right time. And so as we go from daylight, when we're looking with the bay up towards the sun, and say those lights of the sun, we're looking up that way, we would look at the sun for quite a few minutes, measure the sun's output so that we can get an idea of how much it's heating the Earth. And then after about 20 or 30 minutes, David would then maneuver the orbiter to an attitude where we are upside down with our left wing looking towards the sun. And that way we would then watch the sunset. And there are instruments in the payload bay that are looking out always along the left wing, and we can see the sun as it sinks down below the horizon.
We'll have more on the flight of STS-45 in next month's show, when we bring you complete mission coverage of Atlas I.
Veteran Space Shuttle astronaut Vance Brand has accepted a new position as Director of Plans for the X-30 National Aerospace Plane Program. Brand will serve at the NASP Joint Program Office at Wright-Patterson Air Force Base in Dayton, Ohio. During his 25-year tenure at the Johnson Space Center, Brand logged 746 hours in space on 4 flights, including the Apollo-Soyuz mission in 1975. He also served as the commander for 3 shuttle flights, beginning with STS-5 in 1982. In his new job, Brand will help develop the X-30, a flight research vehicle that will take off horizontally, fly into orbit, then return through the atmosphere to land on a runway. Selected as an astronaut in 1966, Brand most recently served as Assistant Project Manager for integration and assembly of the space station. Here now are some crew assignments to tell you about. Astronaut Stephen Nagel has been named commander of STS-55. That's the Space Lab D2 mission, scheduled for launch early next year. Nagel will be joined by pilot Terrence T. Henricks, who served as the pilot for STS-44 last November. Previously assigned crew members are Payload Commander Jerry Ross, Mission Specialist Bernard Harris, Jr., and German Payload Specialist Hans Schlegel and Ulrich Walter. G. David Lowe will serve as Payload Commander for STS-57, which will feature the commercial mid-deck augmentation module called Spacehab. This flight, slated for launch in mid-1993, will be the first shuttle flight for Janice Voss, a member of the 1990 astronaut graduating class. Voss will serve as a mission specialist.
Voss's classmate, Thomas Jones, will conduct his maiden flight aboard STS-60 late next year. Jones has been named mission specialist for the Space Radar Laboratory flight. Linda Godwin was assigned to the same mission as payload commander. Meanwhile, Frank Culbertson Jr. will command STS-51 early next year. He will be joined by pilot William Reedy and mission specialists Daniel Birch, James Newman, and Carl Walls. Culbertson and his crew will deploy the Advanced Communications Technology satellite. And finally, Story Musgrave has been named payload commander for STS-61. Musgrave is the first and only crew member so far assigned to this mission, which will service the Hubble Space Telescope in late 1993. The remainder of the crew will be named at a later date. Over the last several months, we've all witnessed the breakup of the Soviet Union. Well, now, how about the breakup of the Soviet space program? Economic hardship within the new Commonwealth could put some components of the former Soviet space program on the auction block, and the U.S. may be buying. Let's go back now to Anita Vogel in Washington, who's standing by with that story. Anita?
That's right, Tom. A bill that would allow NASA to start negotiating for the purchase of space hardware from the former Soviet Union has been introduced in the House. Representative Dick Zimmer, a Republican from New Jersey, presented the bill to Congress on March 11th. The legislation would permit NASA to make purchase agreements for Soviet-made technology equipment without first getting a license from the State Department. In a statement released by Zimmer, the congressman said just about every piece of Soviet space hardware and technology is on the block at fire sale prices, but NASA is not allowed to do anything but window shop. Zimmer said the things up for sale include the world's only existing space station, the Mir, and the world's most powerful rocket, the Energia. There was, however, no mention of the unmanned Soviet space shuttle, which is believed to have been damaged during re-entry on its maiden flight. NASA officials already are considering the use of Soviet Soyuz spacecraft as an emergency rescue craft that would be permanently docked at Space Station Freedom. Zimmer said the legislation would give NASA immediate access to, in his words, a storehouse of some of the world's finest space material. There are, of course, logistical problems associated with the sale of Russian flight hardware. If, for example, NASA did acquire the Energia, it would have to build a launch facility for it, or ship U.S. payloads to the existing launch pad in Kazakhstan. Both options are remote at best. The Russians are likely to keep their space program in operation for at least one more year, thanks to a little help from Germany and France. Both countries paid $12 million each to place experiments and citizens aboard the Mir. German cosmonaut Klaus-Dietrich Flade was aboard the Soyuz 14 capsule that docked with the space station on March 19th. The link-up was a long time coming for flight engineer Sergei Krikalev, who had been orbiting the Earth aboard the Mir for nearly a year. The cosmonaut blasted off last May on what was supposed to be a regular 5-month mission. But at the end of last year, Soviet authorities decided to scrap a relief flight to save money. This left Krikalev stranded 220 miles above the Earth for an additional 6 months. The cosmonaut returned to a Commonwealth that continues to squabble over the remnants of the space program. Its nerve centers are scattered over several former Soviet republics. Ground control is near Moscow in Russia, the cosmodrome is in Kazakhstan, and some engineering plants are in the Ukraine, which is now locked in dispute with Russia over any project associated with the military. The disagreements, combined with a poor economy, threaten the mere existence of that space program. Adding insult to injury, there's a great deal of discontent amongst Kazakh space workers. In February, thousands of them were sent home after a riot broke out. The workers were being paid almost nothing for performing manual labor at the world's largest spaceport. And you may remember hearing about flight controllers who threatened to go on strike during this most recent mission because they're earning less money than janitors. Well, they decided to stay on the job and instead displayed their demands on streamers in the control room. Signs of the times, I guess. Well, that's it from Washington. Back to you, Tom, in Pasadena.
Thanks, Anita. Earlier in our cover story, we told you about some of the interplanetary probes that are traveling through space. These satellites are monitored constantly by scientists here at JPL, and Richard Horman is standing by to tell us more about where and how this is done. Richard?
Thanks, Tom. We're located at the Space Flight Operations Facility here at JPL, which is essentially the Space Center's answer to mission control. Joining us is Jim Allen, who oversees this facility. Jim, what exactly goes on in this room?
This is the mission control for our planetary missions. We do all of the commanding, receive all of the data back from the spacecraft right in this area.
And does the telemetry come in here directly, or I imagine it has to go through some sort of ground station first?
It comes through the ground station. Let's say the ground stations are located in Spain, Australia, and out in the Mojave Desert here. It comes there and then is radiated here to JPL, where we pick it up and do all of the processing of that data, both in this room as well as up in the other floors where we have our major computers that process the information.
Now, there are about 7 or 8 different stations here. I imagine each has a particular function.
That's correct. Like, for instance, if you take a look here at this real-time tracking function, that person is responsible to ensure that they have the exact location of where the spacecraft is going to be located, ensure that they have the exact predicts for that. He is also the individual that will ensure that the command system and the telemetry system is set up correctly to receive the information that the spacecraft is going to be sending back.
Right.
It's his function to do all of that. And he's got to be responsible for all of the spacecraft, knowing exactly where they are, making sure that predicted stuff is available and processed that way.
Now, specifically, let's talk about the TRACON stations over there.
Okay.
What are they responsible for?
They are to ensure that the tracking stations are set up correctly to receive the information that the spacecraft is going to be sending down to us. They've got to make sure the receiver is set to the right frequencies, the antennas are pointed to the right place, and that all of the individual systems are set up correctly in order to receive it. Their primary purpose is to communicate with that station and to communicate with the mission controllers to know exactly what state that the system is in.
Jim, I imagine that all the planetary probes are monitored from this room.
That's correct. Let's say, for instance, we've got, not for instance, I know we're tracking the Galileo spacecraft, we're tracking the Voyager spacecraft, the joint mission between us and the Europeans called the Ulysses spacecraft, Magellan. Magellan, by the way, is in orbit around Venus at the moment, and we're processing that information. And we are also setting up the Mars Observer, which will be launched in September of this year. So it's just to give you a kind of a view of what it is. But we are also, from this area, processing the information from some of the old Pioneer missions that were launched back in 1964. We're still processing and getting and receiving that information back.
Jim, when a picture comes back from a spacecraft, for instance, the Gasper photo that came from Galileo, does it arrive here in this room?
No, not exactly into this room. This room is supported by a whole host of other computers. The information goes directly to that computer, extracted out of the telemetry data that comes back. And that's where all of the processing is done. In this room, we don't really look at the individual pieces of data that comes back. We look at the overall thing to ensure that all of the data got back. But in terms of what's processed, we don't make that determination in this particular room. We just make sure that all of the information that was sent by the spacecraft is received and processed by the individual telemetry processors.
Obviously a very important role.
If you don't have it, you can't process it. And it's these guys' responsibility to get it back.
Jim Allen, I appreciate you taking the time to talk to us.
All right, well, thank you very much.
Tom, back to you.
Fascinating stuff. Thank you very much for that, Richard. Checking in now on the status of the orbiters for March 1992. The Space Shuttle Columbia remains in Bay 3 of the Orbiter Processing Facility at the Kennedy Space Center. Technicians have installed the Extended Duration Orbiter Pallet, and tests of the Ku-band antenna have been completed. The United States Microgravity Laboratory is to be installed in the orbiter's cargo bay in April. The USML will be the focus of Columbia's next flight, STS-50, which is set for June. Columbia is expected to be rolled over to the VAB for mating with its external tank on May the 9th. NASA is hoping to transport the shuttle stack to the launch pad on May the 14th. The Space Shuttle Discovery continues its major mods period in Bay 2 of the OPF. Discovery is out of commission until December, when it's scheduled to conduct a DoD flight. This downtime is giving engineers a chance to conduct extensive structural inspections of the orbiter and implement a number of modifications, including the installation of a drag chute pod similar to the ones already installed on Columbia and Endeavour. As for the Space Shuttle Atlantis, it was scheduled to undergo the usual post-flight inspections at the conclusion of STS-45. The next flight of Atlantis is STS-46, which will feature the tethered satellite system. The launch is targeted for August. And the Space Shuttle Endeavour is sitting on Pad 39B, awaiting launch in May. The flight readiness firing was scheduled for April 6th, followed by a terminal countdown demonstration test around April 10th. Engineers must first study the results of the FRF before a firm launch date can be announced, but NASA is eyeing May 7th for Endeavour's launch date. It's time now to dig into the Shuttle Vision mailbag. Recently, Shuttle Vision asked a few of its initial subscribers for their comments regarding the show. In response to that request, Steve Carter of Seattle, Washington wrote, "Dear Shuttle Vision, I've enjoyed your product very much until the segment on the January tape of the so-called macho KSC calendar boys. You could have just as easily run a story on the changes that are made on the Endeavour as compared to the other orbiters, or maybe a tour of the visitors area at KSC. I've seen 9 shuttle launches since STS-3 and plan to view Endeavour's maiden flight in May. Obviously, I have a sincere interest in the shuttle program. I have no interest in that January filler story.
From San Diego, California, Philip Sloss writes, Dear Shuttle Vision, I have just finished watching your February issue, definitely the best so far. The story on the Columbia extended duration orbiter modifications was great. It was fascinating to see what the drag chute modification involved. And thanks for all of the orbiter pictures, just what I always wanted. After 3 issues, you're already centuries ahead of the news networks and one of the top sources of information in the space magazine community. Well, not only did Philip Sloss send along those encouraging words, he also sent us some video he shot of the Space Shuttle Columbia at the conclusion of STS-40 last year. This home video was taken by Philip at Edwards Air Force Base on June 14, 1991.
You also don't see it very long from this vantage point when it touches down on runway 22. That was a concrete runway. And if I zoom in enough, you can see the difference between the blankets, which the thermal blankets, which are from basically the aft of the crew module, and the tiles, which are still there. You can sort of see a difference in the scarring or whatever, the charring that they take during re-entry. The blankets seem to take it a little better.
Thanks for the video and the letters, Philip. We appreciate it. Now, if you have some home video of a shuttle, or maybe a picture or two, send them to Shuttle Vision, P.O. Box 92012, City of Industry, California, and the zip on that is 91715-2012. You can also fax us a letter at 818-333-4709.
That closes another edition of Shuttle Vision. Coming up next month, we're off to the Kennedy Space Center in Florida for the flight readiness firing of Endeavour's main engines, and we'll have complete mission coverage of STS-45. For Anita Vogel in Washington, I'm Tom Marshall.
And I'm Richard Horman. We'll see you next month.